Good morning, scientists. Happy Tuesday. Hope you had a great long weekend. Your warm-up is to describe the last experiment you remember doing. So go ahead and get your warm-up sheet out. Make sure you write in the date. Today is September 6th. Pause this while you're doing that. All right, so today I am going to do a quick project introduction. Some of you that were here Friday, I went through this already. If you were here Friday, you can fast forward through this unless you think it might be helpful to review it again. If you were not here Friday, it's going to be important for you to listen to this whole video. We're then going to talk about how to write a testable question, because as you can see, your homework is to come up with a project question and your hypothesis by this coming Thursday, 8 a.m. And today we're going to go into detail about how to write your question correctly. And I'm going to give you some ideas about where to find ideas for those questions. All right, on Friday, I showed you this introductory video clip and asked you as you watched it to come up with the problem or question in this video. Because in this unit, experimental design, we've said that it begins with a question. It begins with a problem. So I'd like you to keep that in mind as you watch this.
Imagine stepping off an airplane here in Bombay, walking to the luggage carousel, picking up your check bag, and then what if I asked you to lift that 20-kilo bag to your head and walk 6 kilometers to the suburb of Bandra? Do you think you'd be able to do it? Do you think you'd even attempt it? In reality, this is the trip that hundreds of millions of women and girls make every single day. But they're not carrying their luggage, they're carrying water. 1 in 7 people globally lives more than a kilometer from the source of the water that they drink. And not much has changed about the way water is moved from point A to point B. It's 20-liter containers carried on the head. And you know what? Water is heavy. Carrying this water causes chronic pain in the head, neck, back, and shoulders. It leads to compression and curvature of the spinal column, which can even lead to death during childbirth. For women like Peppy Devi here, they struggle to collect the 20 liters per person per day that an individual needs to stay healthy and hydrated. Everything you need for cooking, washing, cleaning, drinking. Peppy is only able to really provide her family with about 5 liters per person per day. On top of that, the water that she's spending so much time collecting isn't always safe to drink. 80% of the global disease burden is caused by waterborne illness, and the single most effective way of preventing these illnesses is hand washing. So easy, right? Wash your hands. But when you only have 5 liters of water per day, every single drop is precious. Compounding that is the fact that collecting this water takes a lot of time. Women spend 25% of their time each day, 6 hours on water collection. And let's face it, women have way better things to do with their time. There's a misconception that the poor don't value their time. If that's the case, why is this woman carrying 40 liters on her head, double the typical amount?
Okay, so if you remember, I had you get together with people around you and talk about what is the problem. And clearly, the problem is this water crisis of people having to carry this water that is so incredibly heavy such long distances, and the impact that that has on their health in a lot of different ways. And then I had you start to wonder about possible solutions. Because science, we have said, is the study of God's creation, and that by knowing and learning about his creation, we learn about him. But it's not just about us and getting knowledge. It's a way that we can be used by God for his purposes, for his kingdom, to fix that stuff that isn't the way he meant for it to be. Let's see what they came up with for a solution.
Water crisis is an opportunity. We've reinvented the wheel, and this is it. Thank you. So this is our water wheel, and I'm thrilled to introduce you to it today. You're actually one of the first audiences to ever see it. It's only a couple weeks old. We spent the last 18 months in an intensive human-centered design process, spending a lot of time in the field, listening more than anything else to women like Shantar Bai, who helped us understand what are the features that people want to see in a product like this that would make it valuable for them. The water wheel is as easy to push as a baby stroller. Our cap design prevents recontamination at the point of use, enabling people to store clean water in their homes. It's durable. We designed it in rural Rajasthan to roll over rough, rocky, sandy terrain. The form is inspired by the traditional matka shape, which is a signal to people that it's to be used for clean water. And finally, in recognition of the fact that the people who need products like this the most have the least ability to pay for them, we innovated a business model that's built on incredibly slim margins that pushes us to go to scale and have the impact we want. So our goal is to reach 1 million people in the next 5 years. But there's more. The water wheel, we envision it as a platform for a whole range of component devices, things like filtration, drip irrigation, energy generation. What if you could roll one of these and charge your cell phone or a solar lamp or chill your water?
There were a couple of things she said in this that I absolutely loved. She started out by saying, by reframing this water crisis as an opportunity. I love that. I love that they're taking this problem and seeing it not just as a problem, but as an opportunity. And then did you hear, but there's more? And then she started going on and on about the what ifs and the I wonders. Experimental design helps not only answer the I wonder problems that were as simple as which M&M color dissolves the fastest, but helps us be used by God to solve bigger world problems like this that serve him, serve his people, and make him known, and make his kingdom closer to what he meant for it to be. If you didn't see the Pellagra video that we watched on Friday, make sure you do that, because it's another real world, real life example of how experimental design was used to solve a real world problem. That would be on linked in Canvas as well. All right, speaking of Canvas, you've probably already seen this if you're watching the video, but here is the agenda that we're going to be going through. If you haven't already done this, just go ahead and put in at number 3 the Experimental Design Project Guidelines. If you were here on Friday, you probably already put that into Notability in the Unit 2 subject folder. I introduced this project on Friday very quickly, and I'm going to review it very quickly again today in case you missed it on Friday. If you were here, you can fast forward through that part, but make sure you get this sheet into Notability. You're also going to want to put into Notability the how to write a testable question. That's at number 4. Put that in Unit 2 as well. And then put at number 5 the project question and a hypothesis first draft sheet. So 3 things should go into Notability. The link at number 3, number 4, and number 5. And you can go ahead and pause this while you do that. All right, so if you look at the experimental design project guide, you'll see that I have it formatted in a couple of ways. I have it formatted like this in list form. Your project is going to be to use these experimental design steps to do a very simple project, and we're going to talk about how simple. Again, this does not need to be a science fair, big extravagant project. It can be as simple as one of the M&M questions we came up with. Not one that we already did, but one of the new ones you came up with. You could actually do that. This can be a very simple project. This can be simple enough that you get it finished in an hour. Now, you're then going to need to make a keynote for presenting your project, which you will present in front of the class. It needs to have at least these 11 slides. Now, some of these you may need more than one slide, so you can have more, but you'll need to have these. I've also put the instructions in a picture form, a slide by slide form. So you'll notice the information here and here are exactly the same. But I've also given you a project example of that particular slide. So for the title slide, you can see here, this is Madeline's project title slide. The scientific question slide, number 2, this is just telling you, reminding you that it must be testable, that your question must be specific and must be measurable, that it must include the independent variable and dependent variable, which we'll talk about later today, which Madeline's did. Which brand of sponge, Scotch-Brite or Essential Everyday, will absorb the most water. Slide 3 needs to be the background information. You need to do some kind of research, online research. So Madeline, you can see, she did research about what causes things to absorb water more. So here she found out that damp sponges absorb more water than dry because in her research that she did online, she saw that water molecules are attracted to each other. So then she did some observing, which your background information can include as well. She observed her sponges, and she noticed that one felt more damp than the other. Because of all this research and observation, she made her prediction that the Scotch-Brite sponge will absorb more water. Your background information leads to your hypothesis. Your hypothesis shouldn't just be a guess. It should be based on your research. You should have a why for your hypothesis. I should see in your background information why you chose your prediction. Your hypothesis should be written as an if-then statement. So the if part is literally just repeating your question. If I test which brand of sponge, Scotch-Brite or Everyday, will absorb the most water. This was her scientific question. She just copied and pasted it after the if. The then is your prediction. Next comes your variables. You need to identify the independent variable, the dependent variable, and all of the variables you're controlling or keeping the same. Again, we're going to talk about what each one of these are in greater detail later. I'm just going through this quickly so you get to see where we're going, so you have an idea. But all of these steps are going to be described in much more detail later in the week. Your material slide, every single thing you're using, And then you need to be, again, detailed, amounts, sizes. Your procedure, again, a numbered list, not in paragraph form, a numbered list, including a photo of your setup. A data table, this is where you're going to collect the numbers that you're measuring. You need 3 trials. Now, I've had kids in the past come up to me and say, the way my experiment is, I don't have time to do 3 trials, or the experiment that I'm doing, it would be really expensive to do 3 trials of each. So if for some reason you don't think you can do 3 trials, come see me and we'll talk through it. You'll notice here that she gives the number measured for each trial, and then she finds the average. Because for the average, this is the number you're going to be using in the graph that you make. So you will have one slide that gives the data table with the numbers that you collected and measured. Then I will show you a website and how to make a graph using the data that you collected. The graphs need to have these 5 parts: title, the independent variable labeled, the dependent variable labeled, the scale, and the units labeled. The website will walk you through that. And the conclusion needs to have all 5 of these parts. Again, we'll talk about those. As you can see in Madeline's, you can pause this and read hers. It would be a great template for writing yours. And then you'll get points based on your having at least 10 pictures. You'll need to have a works-cited slide. This is just where you're going to write down the sources that you used. Cannot be Google. If you type in a question and then in Google and then there it gives you the answer, you have to follow it to the website. You can't use Google as a source. And then the slide appearance, grammar, spelling, all of these things are going to be contributing to your effort and appearance grade. This is the rubric I'll use. This honestly is your Google map to getting a 50 out of 50. All right, if you would go to Notability and open the How to Write a Testable Question packet, we're going to go through how to get started coming up with your question and writing it correctly. So what is a testable question? This is one that can be answered by using an experiment. They're always about changing something to find the effect on something else. A sample testable question: does changing the height of the ramp affect the speed of a car going down the ramp? The height, that's what's being changed. The speed, that's what's being measured. These are formats you can use for your question. As a matter of fact, using one of these 4 formats will ensure that you're writing it correctly. Does changing, in this case, the height of the ramp, that's what you're changing, affect what you're measuring, the speed of the car going down the ramp. Now, if you are comparing different brands of something or different types of something, you can use this 4th one. Which brand of sponge will absorb the most water? Which brand of paper towel will absorb the most water? Which brand of paper towel, when wet, will hold the most quarter rolls? You get the idea. In a scientific experiment, these two blanks here and here have special names. These are variables. The first blank will include the independent variable. The second blank will be the dependent variable. The first blank, which is the independent variable, is what you are changing, what you're testing, the different types of sponge, the different types of paper towel, the different heights of a ramp, the different types of paper on a paper airplane. You're only changing one thing. You wouldn't test the height of the ramp and the length of the ramp. You're only choosing one. The dependent variable is what you're measuring. So does changing the type of paper of a paper airplane affect how long it will stay in the air? So in our example of, does changing the height of the ramp affect the speed of the car going down the ramp? The independent variable is the height of the ramp. The dependent variable is the speed. This is what's being measured, and it needs to be numbers. So speed is a number. Time is a number. Length is a number. How much is a number. Here's another one. Does changing the amount of light affect the growth rate of plants? So what you're changing, testing, is the amount of light. That's the independent variable. The dependent variable would be the growth. Now you're not going to want to do anything with plants because you don't have time. Another one. Does the temperature of water affect the time it takes a sugar cube to dissolve? So the independent variable, the thing you're changing, you're going to be testing different temperatures. What you're measuring is how long it takes the sugar cube to dissolve. That's the dependent variable. Okay, this question, how does a paper airplane fly? That is not testable, but we can make it testable. So decide what you're going to be changing or testing, your independent variable. It could be the size of the plane, the style of the plane, the type of paper. Then you're going to decide what you're going to measure. You could measure the distance the plane will fly, or you could measure the length of time the plane stays in the air. Once you've chosen one thing to test and one thing to measure, you put them together to create a testable question. How does the type of paper affect the distance a paper airplane flies? The only thing that I would include here is I would add specific things you're testing. So here, I would add computer paper, graph paper, or construction paper. Affect the distance a paper airplane flies. So I would have you include specifics, like so. All right, I have given you scads and scads and scads of different questions. Not all of these are good, but I thought all I did is I went online and I typed in questions, simple science experiments that can be done with things in your kitchen. Easy science experiments. And you can see I came up with a whole lot here. Again, like I said, some of these are good. some of these aren't good. For example, look at this one. Does a no-name stain remover work just as well as a brand name? The reason that is a problem is because it doesn't tell you how you're measuring. Just as well, I can't measure that. All right, so what I thought, however, is going through a lot of these questions, it might just inspire you to come up with questions that you might like to do. Now, once you come up with your question, you are going to fill out this sheet. So in Canvas, this is the question and hypothesis first draft sheet. This is what you're going to be turning in on Thursday by 8 a.m. So once you have your question, you are going to write it down in the correct form. Now, once you have your question, you can write your hypothesis. Literally, after the word if, put your question in. If I test which kind of paper, construction, graph, or computer paper, will make a plane fly the farthest, then you make your prediction. You don't say, then I think because. You just say, then an airplane made of computer paper will fly the farthest. Now, your hypothesis normally comes after the background information. I'm not paying attention really to your prediction here. I'm paying attention and I'm going to be looking, are you writing these two things, the question and the hypothesis, using the right format? Once you've done your background information, if you change your prediction, that's fine. You can change anything in your final project. This is just a rough draft. What I will do when you turn this in is I will look to make sure that your question is doable, that it is measurable. I'll make suggestions if you've written it incorrectly. For your hypothesis, I'll mainly just be helping you write it in the correct format. Then I want you to just write down, based on your question, what are some things you could research? If you were doing the paper airplane thing, what kinds of things affect flight? Or like Madeline did, she researched what kinds of things make water absorb faster. As far as things you could observe, you could observe what the paper towel looks like, feels like. Some have ridges, some looks flat, some is thinner. So this last section here, you're not writing your background information here. You're just kind of telling me the different kinds of things that you're going to be using for background information. And so I'll look at that too, and I may suggest you're going to need more specific information, or you're going to need more for your background information. This is due on Thursday. I will have it back to you by Friday, because on Monday, the following Monday, you are going to need your final question, your final background information, and your final hypothesis turned in on Monday. So you will be able to take all of the suggestions I gave you and fix anything that was wrong so that your final version is all corrected and good to go. All right. If you have any questions, don't hesitate to come see me before or after school. And as we go on in the week, we're going to be talking more and more about each of the steps. Have a great day.